friends, welcome to Allegiant Stadium. We're going to show you today how we used math to design and construct the stadium. So how did we use math to design the stadium? Well, we started with a vacant piece of property, 62 acres big. 62 acres sounds like a lot, but you have to fit quite a bit in that. Just the building itself to house 65,000 fans takes up 7 acres. And then you have all this other stuff that needs to fit in the site. 2,400 parking stalls, drive aisles, landscaping, you name it. We had a lot to fit in 62 acres. There was so much concrete used to construct the stadium site that you could build a sidewalk all the way from Las Vegas to Los Angeles, 257 miles. That's a lot of concrete. We used a lot of measurements to design this site. Here's one example. We had to fit 2,400 parking stalls within the site. Each parking stall is 9 feet wide by 19 feet long. One other way we use math to design the stadium is elevation. Elevation is the amount of feet above mean sea level. The elevation of the stadium is 2,197 feet. Add on top of that 226 more feet and you get the top elevation of the stadium. That allows us to be just below the flight path and allow airplanes to still fly over top of the stadium.
Welcome inside of Allegiant Stadium. We're down here on the field level. My name is Paul Dudzinski, and I want to show you today the grand scale of this building. The building itself takes up over 7 acres of the project site, and there's about 65,000 seats all the way throughout here. When you start to talk about scale and the size and the magnitude of the building, this isn't something we can fit on one sheet of drawings. In the engineering and architecture world, we use what's called scale, where we draw something at a much smaller size than it really is in real life. So this stadium started as a set of architectural plans on flat paper, all engineered on computers using math and scale and proportion. And so through the use of that, we're able to take the massive size of this building and shrink it down and fit it on various sheets of paper. So when we talk about size and scale and proportion, I've got what looks like a ruler here. This ruler is actually an engineer's scale, where we use a measurement of 1 inch to equal various quantities. Like in this perspective, 1 inch equals 30 feet. That's the same distance from the 10-yard line to the end zone. That's how we're able to fit a building of this size on architectural plans and drawings.
Hi, my name's Bailey Ruff. I'm a project manager out here at Allegiant Stadium, and I worked on setting up all these seats. There's 65,000 seats at Allegiant Stadium, and we're sitting in just one seating section and one row of that seating section. And each seat needed to have the perfect view of the field. So the architects used what are called sight lines to take the line of sight from your eye all the way down to the field to make sure that there was nothing in the way of your view. Each row in the Allegiant Stadium has a different number of seats in it, and that's because each seating section is a different size, and that has to do with the shape of the stadium. So the shape of the stadium is an oval, and each seating section is kind of like a piece of pizza that fits around the oval. It's like the piece of pizza that you took a bite out of. So that means that the closer you get to the field, the least number of seats you have in the row. So we were able to fit 65,000 seats across the whole stadium, and everybody has a great view of the field.